All right, this is the 3-5 video, so if you're watching this, you should be following along, taking notes in your workbook on pages 68 and 69. This information is also shown in pages 119 to 122 in your textbook if you just want to read through it to get a quick refresher. But our goal today is to use a scatter plot to describe the relationship between two data sets. And we have a lot of new vocabulary, but a lot of different words that are kind of used interchangeably, so you'll see some of that. We're going to start with question number 1, which is on page 68. We're going to do parts A and B, and it says describe the type of association each scatter plot shows. So if you forgot what a scatter plot looks like, here I have a graph kind of with just a bunch of points and no line connecting them. That's my scatter plot. I'm comparing X and Y, two data sets, right? So all my values for X and all my values for Y. And so in my notes, I wrote that association and correlation mean the same thing. So we talked about correlation in our vocab. Savas kind of uses them both interchangeably, and you'll see them both in your time in math. So just know when we want to describe the type of relationship, that's called an association or a correlation. And what's nice is positive association and negative association looks just about the same as positive and negative slope. So if I have a positive association on a graph, that means that my data points are trending up. So I have a bunch of points that are all going up from left to right. And a negative association, same as negative slope, means from left to right, my data points are trending down. So as X gets bigger, my Y values are going down. So what is this type of association in part A? I like to draw in my line of best fit, some kind of like average value line to show what's happening with this data, where is it going, and we'll see that this would be a positive association or correlation. And so what else did we talk about in our vocab? We did weak and strong. So again, that line kind of helps because now I can see if this association is weak or strong. And weak or strong in relation to that line that I drew in the middle. How strong is the relationship of the points to that line? And so if all the data points are really close to my line of best fit, then we would call that a strong correlation, like this one is a strong positive correlation, versus if my points were all pretty spread out away from that line, but my line is still going through the middle, I would call that weak. And in part B, you'll see I kind of have a different issue of I don't even really know where the line is going. My points aren't all going up or down. If I wanted to draw a point through the middle of this data set, it would probably be like a straight line almost. And so we would actually call that no association or correlation. Again, you can use either word. So I'll write no association / correlation. Either word is fine. So if it's not trending up or down, there is no relationship between these two things, whatever is on the X and Y axis. And I know these points are a little bit spread out, so you would think it's like a weak no association. But we wouldn't call it weak if there is no association in the first place. So we just say no correlation, no relationship here. And so what are we going to do with that line that we're drawing through my data? So that's called a trend line. Also, we call it a line of best fit. It also has other names. So what trend line or line of best fit in slope-intercept form, so we're going to write an equation for it, models the data from this graph shown. So in my notes, I put a reminder. Slope-intercept is y equals mx plus b. Remember that m is the slope, which is rise over run, and b is the y-intercept, which is my starting point, or where does my line intersect with the y-axis? So if I had a point on the y-axis where my line is crossing through, that would be my y-intercept, right? That would be B. If I had my y-axis and my x-axis, wherever my line is crossing through the y-axis. So what would be the best fit line here? And it can be really hard to draw it by hand. I know our lines are going to be a little bit crooked, but a line of best fit should go through the middle of this data. And sometimes I'll even try to line it up with a piece of paper first, and I'll count. I want my line to go through the middle of this data set, and I want there to be a similar number of points above and below the line. So here's kind of a good, I did okay. I have like 4 points above and 4 points-ish below, kind of that one too. It could have been maybe down just a little bit, and so that's what I'm trying for. So that's what I want, same number of points on both sides. That's the true middle, right? Number of points on both sides. And so we want to write an equation for this line. Again, it can be really hard, especially because in a straight line, my slope should not be changing. I should have one constant slope. But you can see here that like between different points, it's kind of all over the place. But like if I could just find 2 good points, and if you have no good points, you might need to redraw your line. And then I can trace my slope, my rise and run. So make sure you show your work, and even if your line is shaky, I'll understand what you were going for. And so my slope, my rise, looks like it's 4 units up. So that would be my rise. And then my run, how many units over, is 5. That makes sense. It's close to 1. I can see down here, I might have been a little closer to up 1 over 1, up 1 over 1. So that makes sense. And then where is my y-intercept? Here is where I cross the y-axis, right? The y-axis goes up and down. And so that's my b. b equals 0, right? So b equals 0, and my slope is rise over run, so 4 over 5. 4 over 5. And so if I put it into my equation, that's y equals m, 4 over 5, x plus b. And that's my final answer. That's my equation. I could also write it just y equals 4 over 5x, no plus 0, because plus 0 doesn't really change any numbers, right? Plus 0 just gives me the same thing. And so that's a great line for my data. And so part B says, explain why really we could have no data points on the trend line, yet that line models the data. So my line does not have to go through any of my points on the scatter plot. It just has to go through the middle, right? So the line is supposed to be kind of like an average place that's cutting straight through the middle. So the line only needs to go through the middle of the data. I almost think of it like a cloud, and I want to cut right through the middle. And so what's that's like is like an average. So I'm kind of trying to find the average. Okay. So that's my explanation. I don't need it to go through any of the points individually because it just has to go through the middle of the data, like an average. That doesn't mean it crosses through the actual points. It's just going through the middle of the cloud. And so let's apply now a equation to a line for a scenario. So question 3, our last example, says the line y equals negative 0.02x plus 16.4. So they're giving me a y equals mx plus b line. M equals negative 0.02 and b equals 16.4. And that is supposed to model the amount of time y in seconds to download a 170 gigabyte file with an internet speed x in megabytes per second. Whoa. Okay, I don't know a whole lot about computers, but so they're telling me 2 things. So the amount of time to download is y. So the time to download in seconds to download this file. And internet speed is x. So that I think will be important. X is internet speed. And y is how long it takes to download the same file. And so I'm kind of trying to imagine this graph in my head, right? It's starting at 16.4 and it's going down, which makes sense. As my internet speed gets faster and faster and faster with X, right? As my X goes up, my internet speed gets faster. My time to download should be going down, which makes sense with a negative slope. It'll take less and less time to download a file if my internet speed is getting faster and faster. So it asks me, what is the x-intercept of that line? And I don't want to graph this line, especially with a slope of negative 0.02. That sounds hard. So if you remember from last unit, the x and y-intercept can be a little tricky. If I imagine an x-intercept is a point on the x-axis, and on the x-axis, y is 0. That's what I know. So the x-intercept is actually where y is 0. And the y-intercept is where x is 0, right? If I imagine a point on the y-axis, that's where x is 0. Because on my x-axis, that's the 0 point at the origin, right? So it's a little flip-flopped, but I'm going to use that information with my equation to solve it. So I know that y equals negative 0.02 times x plus 16. And now we know that I'm looking for the x-intercept, which is where y is 0. So now what am I going to get? If y is 0, we're going to solve for x. Right? So let me put in 0 for y. I get 0 equals negative 0.02 times x plus 16.4. And I can solve for x, right? So I just plugged in 0 for y. Now I'm going to draw a line through the middle, and I'm going to solve for x, get x by itself. Take away 16.4 from both sides to get rid of that. And I get negative 16.4 equals negative 0.02 times x. So opposite of multiply, opposite of times, is divide by negative 0.02, divide by negative 0.02, and I get 1x. And if I use my calculator, negative 16.4 divided by negative 0.2 is 820. So what does that crazy number tell me? If x is 820, that's if y is 0, right? So when y is 0, x is 820. So that means that tells me if the internet speed is 820, what is that? Megabytes per second. The download time is, right? The download time is y. The download time is 0 seconds. Is that possible, right? So that's the last part of that question. Is that possible in the real world? So sometimes we look at our data and then we draw a long line, right? Like we talked about in last unit, a long line with arrows on both sides that goes on forever. And is that really possible at every point? Sometimes it makes sense for most of the scenario, but not really for every part of the scenario. And this is not really possible, but it's probably really close. So, if I have a super, super fast internet speed, I'm sure that it's getting closer and closer and closer to 0. But is the download time ever going to actually be 0? I can't really just download a file instantly, right, with no seconds at all. Maybe it'll be 0.0001 seconds, but I can't download something instantly, no matter how fast my internet speed probably is. Maybe one day it'll be 0.0001 seconds, but something like that, you kind of have to interpret my answer for the scenario and connect it to that and really think about, what is this saying? What are x and y? And if I find a pair of x and y, numbers for x and y, how can I connect them back to the situation? So I would say that's not really possible in real life. I can't instantly download a file. If you want to see another example, here are 2 more scatter plots with the table of the values also and 2 lines of best fit. Another example of how I want some points on both sides, an equation, even though I thought the equation was a little bit confusing at first. remember, if it's just x, that's 1x, and if the slope is 1, that's 1 over 1. But next on your checklist, you can update. So you watch the video, you took notes. Maybe you'll need to watch it again, but you can move on to those practice problems, the 3-5 practice on Sabbath. Good luck.